The future of Gwangyang Harbor will be reborn. The future of Cheollonamdo will be reborn. As the hub of international logistics and maritime tourism. As the powerful driver of Cheollonamdo's economic growth. A new history of construction representing 21st century Korea will be written. The new landmark of the Gwangyang Free Economic Zone. The construction of the Yisun-shin Grand Bridge. The purpose of this construction is to improve the basis for development of Southwest Coast tourism and the transportation distance between Yeosu and the Gwangyang National Industrial Complex. It is taking place in Yeosu National Industrial Complex Access Road Construction Zone 3. The construction is of a super long span suspension bridge, which is 2.26 kilometers in length with 3 spans. The span of the Yisun-shin Grand Bridge is 1,545 meters. This will be the 4th greatest super long span suspension bridge following Akashi, Shihoman, and Great Belt suspension bridges. It will secure enough span length for container ships of up to 18,000 TEU to cross both ways in order to correspond with the prominence of Gwangyang Harbor, which will rise as the hub harbor of international logistics. It is being formed as a floating suspension bridge with 3 spans without expansion joints and support in order to minimize maintenance. In particular, the bridge is being constructed in symmetry to maximize its beauty as the representative bridge of Korea. The new trend, twin steel box, is being adopted as the stiffening girder to ensure economic efficiency and aerodynamic stability. A twin steel box is a cross-section that is optimized to reduce the weight of the bridge deck, maximizing aerodynamic stability by minimizing the effect of wind through the opening. 5-centimeter epoxy asphalt is being applied as pavement for durability, weight reduction, and resistance against chemical materials. This is a new method of construction, and its result and performance has been proven in long-span suspension bridges, such as the Golden Gate Bridge of the United States and the Runyang Bridge of China. With its world-class technology, Daelim has been leading bridge construction in Korea. Daelim has constructed the Sohae Bridge, Korea's first steel-concrete composite cable-stayed bridge, and has designed and built the Samcheonpo Bridge, the first cable-stayed bridge which is purely a work of domestic technology. The company also completed the Sorok Bridge, which is Korea's first monocable self-anchored suspension bridge. Furthermore, Daelim is in the midst of constructing the Saepung Bridge, a 6-span cable-stayed bridge. The second Dolsan Bridge, a continuous 5-span concrete cable-stayed bridge. The Jokgum Bridge, a single-span suspension bridge. The Dandung Bridge, a single-span single-pylon suspension bridge. The Saechunmyeon Bridge, a suspension bridge with 3 pylons with 4 spans. And the Yisun-shin Grand Bridge, which boasts the world's 4th longest span of 1,545 meters. The pylon of the Yisun-shin Grand Bridge will be 270 meters high, which will make it the highest concrete pylon suspension bridge in the world. The bridge will symbolize the dynamism of Gwangyang Harbor's reaching out to the world by the harmony of its magnificence and the beauty of Korean traditional curves. Before constructing the foundation of the pylons, though, construction methods such as SCP and DCM, the weak ground is being strengthened by building artificial islands with block inner walls and internal reclamation work. The SCP method utilized special marine equipment to build a 2-meter diameter sand pillar, and the replacement rate was 40%. The DCM method utilized special marine equipment to build cement piles, and the replacement rate was 60%. After strengthening the weak ground, a riprap mound was built, and the inner walls were installed using concrete blocks. The artificial islands were filled with sand, and these islands will protect the pylons against ship crashes. This has been confirmed by crash simulations. After the artificial islands were completed, 38 3-meter diameter concrete piles were constructed per pylon. Sacrifice steel pipe type was applied for maintaining hollow walls. A steel net inserted in the cast-in-place pile was assembled mechanically at the site by using spiral band steel. Underwater concrete was placed in the steel pipe with the steel net inside, followed by pile cutting work. Then the foundation for the pylon was constructed. The foundation of a pylon is 70 meters long, 30 meters wide, 8-meter high concrete, and the 80,000 tons of weight on the pylon were transferred equally to the cast-in-place pile. The pylons were constructed by slip-form method, which was applied with a cutting-edge, detailed configuration survey system for the safety of the construction and to reduce the construction period. The slip-form method used a hydraulic oil pressure system, which raised the mold automatically instead of detaching it, that simultaneously placed concrete. This method was very effective in shortening the construction period and increased the efficiency in construction. In particular, the pylon of the Yisun Shin Grand Bridge has a slant due to the narrowing shape of the cross-section. Therefore, the configuration survey was essential. For this reason, a configuration survey using laser and light wave measurement allowed for high-quality construction without any errors. After the pylon legs were built, 2 cross beams connecting the pylon legs were installed. For the construction of the cross beams, the heavy lifting method was applied, where cross beams were produced in advance to shorten the construction period at the pylon foundation and lifted with hydraulic jacks. The heavy lifting method used 20 80-ton hydraulic jacks and 15.2 millimeter wires to lift 1,300-ton cross beams, and the installation process was as follows. First, when building the pylon legs by using the slip-form method, a temporary bracing in the middle of the cross beam was installed to prevent pylon deformation, and then the pylon legs up to the top of the tower were constructed. Next, in order to install the heavy lifting materials, slip-form materials that may get in the way were removed or added. When doing this, if there was sufficient working space, derrick cranes were used to install the materials for lifting. At the same time, at the foundation of the pylon, the upper cross beam on the ground was produced beforehand with steel beams installed in order to ensure the stability of the heavy lifting and the connection with the pylon body. When the installation of the heavy lifting materials was completed, the wire clamped with a hydraulic jack was connected to the upper cross beam, then lifted with a hydraulic jack to temporarily fix the connecting part on the pylon and the steel beam installed in the upper cross beam by welding them together. After the temporary fixation, the erection of the upper cross beam was completed by placing concrete for the connection between the pylon and the upper cross beam. The method of connecting the lower cross beam is equivalent to the top cross beams. However, since the total weight is approximately 4,000 tons, only 1/3 of it was built beforehand at the foundation of the pylon. Then it was lifted and connected. Finally, the pylon was completed by placing the rest of the cross beam at the location where the lower cross beam was installed. The anchorage that supports 40,000 tons of tension on the main cable is a crucial part on a suspension bridge, and different methods were applied in Myodo and Kwangyang. The anchorage on Myodo applied the earth anchoring method, which supports the cable using the self-weight of the bedrock after settling a cable on stable bedrock. Earth anchoring is an economic and environmentally friendly method that minimizes the exposure of the structure. where a 6-meter diameter, 33-meter deep vertical hole was excavated, then a 72-meter long triangular chamber. Strand holes were punched using a Symmetrix casing system in order to ensure the precision of drilling. 68 230-millimeter diameter and 36-meter deep holes were drilled. Then upper and lower anchor plates were constructed for jacking. Finally, the anchorage was completed by jacking strand along with building vent and shed, which is the upper structure. The anchorage of the Kwangyang side applied a gravity method that supports the cable by using the self-weight of the concrete placed in the basement rock after excavation, in consideration of the weak ground. The order of the construction was as follows. First, a site via landfill was constructed. Then the ground was reinforced by the SCP method. Next, to enable excavation without further reinforcement, a 1.4-meter thick slurry wall was constructed. The internal diameter of this wall is 68 meters and the depth is 33 meters. When the slurry wall was completed, the sand and soil deposits inside were excavated. When the excavation was complete, the founding concrete was placed. Then an RCC was used to fill the space inside. Then 16-meter concrete was placed to make the form of an anchorage. When this was done, the anchorage was completed by constructing the vent and shed. The air spinning method and vertical lifting method were applied for the erection of cables and stiffening girders. Once the pylon construction was completed, temporary structures for cable installation, vents, and saddles were installed on the top of the tower. On the anchorage, saddles were installed first, then the vents. A temporary hauling system is formed by connecting the entire bridge with pilot rope by using a tug to install a catwalk, which is a mid-air working area for cable installation. Utilizing the rope of the temporary hauling system, 10 catwalk ropes on both upbound and downbound lanes are installed. Next, the floor on the catwalk rope at the top of the pylon is slid to complete the catwalk, which is an area for working in mid-air. On top of the completed catwalk, a tramway support rope, gallows frame, and cable former is installed. Then the temporary hauling system is modified, which only enabled one-way transportation to enable two-way travel. An air spinning wire supply facility is placed at the back of the Kwangyang side anchorage. Then the preparation for cable installation is ready. Air spinning starts when the hauling system operates with 4 wires fixed near the splay saddle at one end wind on the strand shoe and spinning wheel. While the spinning wheel moves from the Kwangyang anchorage to the Myodo anchorage with the wire, the non-moving dead wires will be put inside the saddle and the cable former. The live wires being supplied twice as fast as the moving speed of the spinning wheel will be put on the roller next to the saddle and the cable former. Meanwhile, the tension of the wire will remain constant by the tension control tower. When the spinning wheel arrives at the Myodo anchorage, the slacking process, which loosens the wires near the anchorage, will take place. Then the wires will be detached from the spinning wheels, wound on the strand shoe. Then the slacking will be taken apart. The spinning wheel will be returned to Kwangyang, lifting the wires on the roller, and will put them down inside the saddle in the cable former. This way, no wires are supplied while the spinning wheel returns. When one strand consisting of 400 wires is completed, it will be tied in a circular form in order for measurement and shape adjustment to occur. After the completion of air spinning between the main spans, 2 strands in the side spans will be additionally constructed in similar ways. Then the cable compaction process will take place, which makes the strands into round cable form. Then, the cable process for the stiffening girder installation will be completed by the installation of cable band and hangers. The installation of the stiffening girder applied vertical lifting method will not occupy the major seaway in order for the function of the international harbor to be maintained. State-of-the-art lighting will be installed on the bridge to bring about a beautiful view at night. Such tourist facilities will be made into the tourism belt linked with tourism development programs and will vitalize regional tourism as well as becoming an international tourist attraction. A future city where life is rich. Green Chalanamdo. As a symbol of oceanic Korea, as the new pride of Chalanamdo, this will set a milestone in Korea's construction history. The new landmark of Kwangyang Free Economic Zone, the Yi-Sun-shin Grand Bridge. With its technology and know-how, Korea's leader in bridge construction, Daelim, will make the safest and most beautiful bridge in the world.